An electron accelerated by a potential difference of 1 kilovolt moves in a uniform magnetic field at an angle of 30 degree to the vector B, whose modulus is 29 millitesla. Find the pitch of the helical trajectory of the electron in millimeter. Yeah, we have to find out the pitch. So whenever a charged particle moves at an angle to the direction of magnetic field, suppose if a charged particle is moving in a direction like this to the magnetic field, then suppose the magnetic field is in this direction and the motion of the charged particle is like this. Then one component of this velocity, that is v cos theta, will take it along the direction of the magnetic field, and another component of velocity, v sin theta, like this, v sin theta, will make it to move in the circular path. So this is v sin theta. So this motion is perpendicular to the magnetic field B, and this will make it to move in the circular path, whereas v cos theta will take it forward without changing the direction. So the two velocities simultaneously will act on the charged particle, and if the charged particle is positive, it will move like this. So if the circular path is created because of this vertical velocity, vertical component, and the horizontal movement is because of v cos theta. So both the velocities will act together. Now, what do you mean by pitch of the helix? The horizontal distance traveled, that means horizontal in the sense the distance traveled along the direction of motion, direction of magnetic field. The distance traveled along the direction of magnetic field in a time of 1 period, that is pitch. So if this is the helical path of a charged particle moving at some angle to the magnetic field, by the time it completes one full rotation, 1 period will be over, and by that time it won't be rotating at the same position. It will be moving forward. So it will be moving little bit forward like this. So this is pitch x. So the motion x along the direction of magnetic field, that is because of v cos theta, the cos component of the velocity. So we can split the velocity into two components. One along the direction of magnetic field, that is v cos theta, that will take the charged particle along the field, and that will take it forward. So this x motion is because of v cos theta, and v sin theta will make it to move in the circular path. Now, if you know v, this distance traveled x in a time of 1 period, because by that time the charged particle has completed one full rotation like this, one circular path. Now we can write v cos theta is equal to the distance traveled by 1 period, because that x is traversed along the direction of the field in a time of 1 period, in a time of one rotation. Now we will find out different values. Now, since the charged particle is accelerated through a potential difference, we will have to find out what is the velocity of the charged particle by the time it enters the magnetic field. So we know that the kinetic energy, is gained by the potential energy of the charged particle when it is placed in the electric field. So charge into potential difference is half mv square, which implies velocity of the charged particle is square root of 2qv by m. So that can be substituted here, v instead of v cos theta. This v is a potential difference v, 2qv by m. Yes, this is potential difference. Now, so time period of rotation. If you want to know that, you can compare the centripetal force as the force experienced by the charged particle because of magnetic field, that is mv square by r is equal to qvb sin 90. We know that. So that comes to, if I want to know, velocity can be cancelled. V is equal to qrb by m, which is also equal to the distance traveled in one full rotation by time taken, called period. So Comparing this, you can cancel r and t equal to 2 pi m by qb. This, and if you know this formula, you can use it directly. So period is 2 pi m by qb. So we have got velocity and we have got period. So now substitute in this basic formula. We know that the cos component of velocity moves it by a distance x in a time of 1t, and they have asked you to find out what is the pitch of the helix. Pitch is x, so x is equal to v cos theta into t. X is equal to v is square root of 2q potential difference by m cos theta into time. Time is root of, no root. Time is 2 pi m by qb. Time is 2 pi m by qb. Now we can minimize this formula. X is equal to, so you can bring this 2 q m inside, so that you can use it along with the 2q v by m already that we have here into. So I can take this q as a q square here, square root of, and m square here, m also taken inside, and you can take this as 4. This square root of 4 is 2, and remaining things are pi and q have taken, b not taken, pi by b and cos theta. So now finally the formula pitch of the helix is equal to root of square root of 2q, q gets cancelled, 2v by q, because here you can have 1q cancel, m gets cancelled here, and m is here, and 4 into 2 will be 8. I can replace this as 8. 8 v by q into m into pi by b, that is outside, cos theta. So the formula lies like this now. You can substitute the values. So x is equal to root of 8. Potential difference is 1 kilovolt, I think. Yes, 1 kilovolt, 10 to the power 3 volt. And m, it is an electron. So mass of the electron is 9.1 into 10 to the power minus 31 kg. Charge of electron is 1.6 into 10 to the power minus 19. Pi is 3.14 divided by the magnetic field is 29 millitesla, 29 milli cos theta, cos of 30 degrees. So cos 30 degrees is root 3 by 2. So this has to be calculated now. X is equal to root of 8 into 9.1 can be taken as almost 9. Here I think we can take 116 into 10 to the power minus 1 if I take. Then it will be 10 to the power minus 20, this one, because I have taken this as 16, minus 20, when it comes to the numerator, plus 20, 23, 23 minus 31, it will be 8, 10 to the power 8 into 3.14 by 29 into 10 to the power minus 3, cos 30 is root 3 by 2. So this has to be calculated, and final answer will be almost equal to 19.3 millimeter. Actually 0.193 meters you will get. 19.3 millimeter, which can be written as almost equal to 20 millimeter. This is the answer. Thank you.